This is Evan with EB3D Printing. Today I'm going to go over the installation process for the Bondtech DDX V2 extruder on the Ender 5 Plus. First, I'd like to make a disclaimer though that all the products you see in this video I supply with my own funds. This video is not sponsored in any way. I would, however, like to make a special shout out down to Tiny Machines for getting me this extruder rather quickly. I ordered it on Sunday, it was in my hands on a Tuesday. So thank you again, Tiny Machines. But that's enough for me. Let's get into this installation.
For step 1, you want to make sure the power is off. So flip the switch and pull the plug and you should be good to go. Next, we are going to go over the tools you will need. First up is a 1.5mm hex key. Next is a 2mm hex key. Third, but not mentioned, is a 2.5mm hex key. Next up is a 10mm wrench. You'll also need a pair of cutting pliers. It's listed that you'll need this PTFE tube cutter, but you will not need it for the disassembly process. For step 3, we're going to relax the carriage belt. You use the 2.5mm hex key to loosen these two bolts on the top. Once you have them loose, just press on the belt tensioner to give the belt a little slack. For step 4, we're going to detach the belt. So just pull up and twist on the belt end to remove it from the slot. For step 5, we're going to remove the radial fan. You'll want to use the 1.5mm hex key to loosen these bolts. I did this step a little backwards by starting with the bolts at the top. Well, at least I tried to. This one gets a little stuck. Once you have the two bolts at the top loose, you can move to the bottom and start to loosen them. They use the 1.5mm hex key as well. Once you have all four loose, you'll want to be careful with the fan. The wires are pretty delicate. But remove all four bolts and set them to the side and save them for later. This fan shroud you can put somewhere else because you will not need that anymore. For step 6, you'll want to cut the main cable zip ties. You'll be using a pair of cutting pliers for this, and cut any zip ties that are holding the hot end cabling in place. I have the extra step of removing this cable strain relief. Next up, we are going to remove the hot end cover. You're going to use the 2mm hex key to loosen both bolts. First, we're going to start over here on the side of the BLTouch and then screw that one. There, that bolt goes. Next, we're going to move to the top and unscrew that as well. Once you have this loose, grab the hot end cover. Be careful as you pull it away because the BLTouch will fall away as well. You also do not want to damage the thermistor or heating element wires. Just gently lay them over here to the side. Next, we are going to remove the BLTouch bracket. You're going to use the 1.5mm hex key to loosen these bolts. Doesn't matter which one you start with. I'll start with this top one, remove that, then move to the bottom and take the bracket off. You can set the bracket to the side because you will not need that later. But again, be careful with the BLTouch as you do not want to damage it. For step 9, we will be removing the fan shroud from the axial fan. You'll want to use a 2mm hex key for these bolts. You'll also want to store these bolts in a safe place because we will be needing them for the installation process. Again, with these fans, you'll want to be careful with the wires because they are delicate. These top bolts are also kind of tricky to get to, so I kind of wish I had a magnetic screwdriver. And right there is why I wish I had a magnetic screwdriver. Again, store these bolts in a safe place, and the fan shroud you can set aside because we will not be needing that later. For step 10, we are going to be removing the push fit connector as well as the PTFE tube. You're going to want to use the 10mm wrench to loosen the push fit connector. Once you have it loose, you can use your fingers to unscrew it the rest of the way. Now, since the hot end isn't heated, the PTFE tube may be a little snug, so give it a yank. Once you have it out, you just set that to the side. We will not be needing that later. For step 11, we will be removing the hot end from the carriage. You'll want to use the 2mm hex key to loosen the bolts holding the hot end to the carriage. Now, I did not take these bolts out one at a time because they have washers on them. These washers you will need to save later. Again, be careful with the hot end assembly because the wires are really delicate. As you take these bolts out, be careful because of the washers. These are the two washers that we will need to save for later. For step 12, we will go over the parts you will need. First, the radial fan bolts. Next, the BLTouch bolts, the axial fan bolts, and the lock washers for the hot end. Next is the parts no longer needed. First up is the BLTouch bracket. Next is the axial fan shroud, followed by the hot end cover and bolts. The Capricorn tube, I'll go over that a little bit more later. The PTFE tube push fit connector, and the hot end bolts.
So that was it for the disassembly of the stock hot end configuration on the Ender 5 Plus. Now, let's get into installing this Bondtech DDX V2 extruder. But first, I have a special installation of the Slice Engineering bimetal heat break on the stock hot end.
First up, we're going to go over the tools you'll need. You'll need a 1.5mm hex key, a 2mm hex key, followed by a wrench to fit the nozzle and an adjustable wrench to fit the heater block, a Phillips head screwdriver for the thermistor bolt, and the Slice Engineering bimetal heat break. Next up, we are going to remove the heating elements. First, remove this silicone sock. Next, you will need a 1.5mm hex key to loosen the set screw holding the heating cartridge. Do not back this out the whole way, just back it out enough to where it's loose. Next up, you'll need the Phillips head screwdriver to remove the thermistor bolt. Be gentle with these because the wires are very delicate, but pull them out slowly. Set them over to the side, and that is the removal of the heating element. Step 3 is the removal of the heatsink. You'll want to take the adjustable wrench and the nozzle wrench, put the adjustable wrench on the heater block, and then the nozzle wrench on the nozzle. If you've tightened this down when the nozzle was hot, it may be a little snug. Depending on the condition of the nozzle, you may want to replace it. Next up, you want to take the 2mm hex key and loosen the bolts holding the heater block to the heatsink. Once you have them loose, take them out and set them to the side. After this, you'll want to take the 1.5mm hex key and loosen the set screw holding the heatsink to the heat break. Again, do not remove this, just back it out till it's loose. And then slide the heat sink off of the heat break. Step 4, we're going to remove the heat break from the heater block. I do not recommend the method I used to do this, but I used a pair of vice grips with a piece of toolbox shelf liner on the heat break. The adjustable wrench goes on the heater block. Loosen slowly, and once you get it loose enough, you can turn it the rest of the way by hand. The toolbox shelf liner worked really well for this. If you look and see, you can see there's barely any damage to the heat break. Step 5 is a fairly straightforward step. We're just going to be installing the new bimetal heat break. As you can see, that's the bimetal heat break. I'll set that aside. I'm going to be installing a new nozzle for this. You can use the old one if it is still good, but just screw that in till it's hand tight. And then take the bimetal heat break and screw that in from the opposite side, also tightening that by hand. For step 6, we're going to reassemble the hot end. First, we're going to take the heatsink and slide it onto the heat break. Use a 1.5mm hex key to tighten the set screw. Next up are the 2 bolts that hold the heater block to the heatsink. Use the 2mm hex key to tighten them down. Just check to make sure it's properly aligned. Next, you'll want to take the heater cartridge and thermistor and gently place them into the heater block. Put in the Phillips head set screw and tighten that down. Next, you'll want to take the 1.5mm hex key and tighten the heater cartridge set screw on the bottom of the heater block. And then finally, you'll want to replace the silicone sock over the heater block. So that was it for the installation of the bimetal heat break. Now we are going to move on to unboxing the extruder. When you open the box, you are greeted with this nice congratulations card from Bondtech, so thank you, Bondtech. This is the extruder accessory kit. This includes everything you need to install the Bondtech extruder, piece of Capricorn tube, some zip ties, the extruder motor extension cable. This is a piece of PTFE tube fitting. Here's the thumb screw that tightens down the extruder gears onto the filament, and it also includes all the hardware you need to install the extruder. So here's the moment you've been waiting for. Here's the extruder. Look at that thing. It looks amazing. I'm excited about this. The main reason why I went with the Bondtech is because of the pancake stepper motor. That just means less weight on the gantry as it tries to, move around the print. It's also using ABS, or printed nylon, I should say. That also means less weight compared to like the all metal frames that are out there. Here are the accessories that come with the kit. This was the DDX adapter set. This is the adapter set if you are using the stock 4010 radial fan. That is the mounting bracket. This is the adapter that goes onto the top of the hot end. This is a printed BLTouch bracket, and all of the white parts you see here are STL files that are included on the Bondtech website. This is the PTFE tube cutter that we mentioned earlier in the first part of the video. And this is the 5015 radial fan set or kit that you can upgrade from your 4010 fan to a 5015. Step 0.1. These are the Ender 5 Plus bed rod lowering brackets. These are the brackets to lower all 4 bed rods. They're necessary because if you do not have these, the nozzle on the hot end will end up hitting these metal brackets here. You want to use the 2.5mm hex key to loosen all of the bolts that hold the bracket in place. You'll start with the pinch bolt that holds the rod, and then start on the 2 bolts that hold the bracket to the piece of 2020 extruded aluminum. Once you have those bolts out, you just take the bracket off. You can slide the new bracket on and basically reverse the order. Put the bracket bolts back in that hold it to the extruded aluminum. Once you have those tightened down, you can insert the pinch bolt that holds the rod in place. You just screw it in. Now, at this point, do not tighten it down. Once we have that somewhat snug, what isn't filmed is I loosened the pinch bolt on the lower bracket. Once that lower bracket pinch bolt is loose, you'll be able to slide the rod down. So you slide the rod down till the top of the rod is level with the top of the bracket, and then tighten the pinch bolt down, and then retighten the lower pinch bolt. You'll want to repeat this process for all 4 brackets on the top. And that is it for installing the bed rod lowering brackets. Like the previous sections, we're going to go over the tools you'll need. First, a 1.5mm hex key. Second is a 2mm hex key, followed by a 2.5mm hex key. Next is the 3mm hex key. You will also need a pair of cutting pliers, and then some sort of knife that fits inside the PTFE tube cutting fixture. Step 2 is checking the extruder stepper motor wires. You'll want to make sure these middle pair of wires are twisted. If they are not twisted and you connect the extension cable from Bondtech, you risk damaging the stepper motor. Step 3 is installing the hot end adapter. You'll want to fit the hot end adapter to the top of the hot end. You'll want to make sure the flat face is aligned with the front face of the heat block. You'll also want to make sure the mounting holes are aligned. Next up, you'll want to take 2 M3x20 screws supplied in the kit and fit them with the lock washers from the stock bolts on the hot end. You'll want to put 1 washer on each bolt. After you have the washers on the bolt, you'll want to place them in the hot end adapter and hot end. The holes may be a little snug, so you may have to screw the bolts in, but you don't have to screw them down tight. You just have to make sure they're in so the adapter does not fall off the hot end. Next up is cutting the Capricorn tubing to spec. You'll want to insert the Capricorn tube into the top of the adapter, push it all the way down, make sure it's up against the nozzle, then take the cutting fixture and press that against the adapter. You'll want to take the X-Acto knife and cut the tubing as square as possible. There should be 5mm of tubing sticking out of the top of the adapter. Make sure to place the blade protector back onto the blade. For step 5, you'll want to check the fan wiring. You'll want to make sure they're not broken or damaged in any way, and that they are tucked into their appropriate channels. Step 6 is installing the hot end into the DDX. First, you'll want to take the 2.5mm hex key and loosen the 2 bolts on the back of the DDX. No need to take them all the way out, just back them off so it's loose enough to separate the 2 halves, about 2mm. Next, you'll want to insert the hot end into the DDX. They recommend taking the bolts all the way out. I did not do that. I just backed them out far enough to where they didn't stick out of the back of the hot end. Once you have the hot end in, you want to make sure the bolt holes align with the holes on the back of the DDX. And there goes a wrench. Now that you have your wrench securely in your hand, you can tighten the, maybe not. Now we'll tighten these bolts down. You don't have to tighten them all the way because you're not really threading them into anything. You just want them sticking out far enough to where they are into the holes in the back of the DDX. And then you want to tighten down the bolts on the back of the DDX so the hot end is secure. There goes the hex key again. This is the part where I actually screwed up. Well, when I mentioned earlier about placing the adapter onto the top of the hot end, I actually put it on backwards. So I had to take out the adapter, as you can see, and rotate it 180 degrees. So you'll want to make sure the flat face of the adapter is towards the long end of the heater block, and then insert your bolts back into the adapter. Again, don't put them all the way down. You just want them far enough in so they're secure. And then we'll go through that process again of inserting the hot end into the DDX. I don't need to repeat myself. We'll just go through the video quickly and put the hot end back in. and there is the hot end inserted into the DDX. Step 7 involves mounting the DDX. You'll want to cut any zip ties that are holding the main cabling and tubing together. Next up, you'll want to make sure that the front radial fan wires are tucked into the appropriate channel on the side, and also the wires are tucked into the appropriate channel on the back. Next up, you'll want to make sure these two mounting pins line up with the holes on the back of the DDX. You'll then want to take the 2mm hex key and lightly tighten these bolts. They're M3x20s. At this point, you do not need to have the bolts completely tight, just enough to secure the DDX to the mounting bracket. You also will not want to have them too tight because you could pinch the wires on the back of the DDX. And there goes the hex key again. Once you have the two bolts secure, you'll want to check the back of the DDX to make sure there are no pinched wires. For step 8, we're going to be installing the radial fan. I opted for the 3D printed 5015 version. I used two M3x20 bolts to hold the mounting bracket onto the radial fan. There's also a threaded nut inserted into the mounting bracket. This is the M3x10 button head screw. There's a small slot on the inside of the DDX that the M3 screw goes into. It is very difficult to get this to work properly. To get this to work right, I actually had to use a magnet to hold the screw in place while I put the fan shroud bracket in place. There goes the hex key again. You'll want to tighten this bolt down to where it is snug, but you can still move the fan shroud. You'll want to move the fan shroud to where it's about 2mm above the nozzle tip. Step 9 is installing the stepper motor cable extension. You'll want to plug the extension cable into the existing stepper motor cable, and then once that is plugged in, you'll want to guide the stepper motor cable through the cable management groove on the side of the DDX. Step 10 is the zip tie on the back of the DDX. You'll want to make sure all of the cables line up with the appropriate groove before you tighten down the zip tie. Step 11 is installing the front axial fan. Once you made sure the DDX is secure and tight and that there are no pinched cables, use a 2mm hex key to thread 3 of the stock fan bolts into the 3 threaded metal inserts. Step 12 involves placing the PTFE tube. When I mentioned earlier that we'll be going over this, here's what I meant. The Capricorn tube has a 3.95mm diameter, where the PTFE tube actually has a 4.2mm diameter. You'll want to use the PTFE tube instead of the Capricorn because if you use the Capricorn, it has a chance of slipping out of the push fit connector on top of the DDX. After you have the PTFE tube in place, you'll want to use these supplied clips that attach the hot end cable to the PTFE tube. For step 13, we'll want to remove the extruder hinge. You'll want to use a 2mm hex key to, well, try to. Alright, you'll want to use a 2mm hex key to remove the spring compression bolt, and then use the 2mm hex key to remove the hinge bolt. Take out the spring to release tension off of the hinge so it's easier to remove the hinge bolt. Once you have the hinge off, you'll want to use a 1.5mm hex key to loosen the set screws on the drive gear. Once both of those set screws are loose, you just remove the drive gear. Step 14 is not in the guide, and that is attaching the BLTouch. I used the 3D printed BLTouch bracket from the STL file on the website. First, you slide the BLTouch cable through the slot on the bracket and then attach it to the BLTouch. You put the BLTouch into the bracket and then use the existing BLTouch screws. You use a 1.5mm hex key to attach these. It would be easier if you pre-threaded the holes instead of what I did is try to thread them while I was attaching it. I previously tried to install this, but I ended up breaking the bracket, which actually worked out in my benefit. It made the BLTouch easier to install. I used a M3x8 bolt to hold the bracket to the DDX. Pretty much just slide the bracket the whole way up. That'll give you enough of an offset between the BLTouch probe tip and the nozzle tip. I had to remove the left side belt here to make it easier to install the BLTouch. So if you had to as well, just make sure to reattach the belt onto the left side of the hot end bracket. Step 15 involves reattaching the belt. On the right side here, it might be a little tight if you use the 5015 fan, but just pop the belt back into the slot. Next, you'll want to place the belt tensioner back into the extruded aluminum, making sure the T-nuts are loose enough that they'll grab the extruded aluminum. You'll want to use a 3mm hex key to tighten down the bolts on the top, but just tighten them enough to where they're snug that you can still move the tensioner. I used a screwdriver to give the belt tensioner a little more tension, and then once it's at the right tension, you just lock down the tensioner bolts. You also want to check after it's tensioned that the X carriage moves freely. Step 16 involves inserting the thumb screw. First, you'll want to load some filament into the DDX. Then you'll want to insert the thumb screw, tightening it the whole way down, and then backing it off 1 to 2 full turns if you are using hard filament. Step 17 involves cable management. This is all personal choice, but these are the points I chose to use for zip ties and cable. In this section, I'm going to do some before and after comparisons. For our first comparison, we are going with the tried and true chip cube. First up, we'll take a look at the stock chip cube. If we take a look here at this first layer, it's, absolutely perfect. I don't think you could ask for a better first layer. As we look at the sides though, it doesn't look as well. The overhangs bulging in the corners. Like I said, the overhangs of the letters, there's drooping there. The back looks decent, except for the layer lines. That doesn't look good at all. All of the overhangs are pretty much sagging. Top layer, there's some gaps in the top layer, so I guess there's under extrusion problem. Next up is we'll take a look at the BMG, and the first layer, it definitely does not look as good as the stock setting. Under extrusion here on the one side. The overhangs on the letters look better, but again, we're still dealing with these weird layers shifting, and we also have some bulging in the corner still. Not nearly as severe as the stock setting, but it's still there. These zits are definitely from the time lapse. I'd have to fine tune, the settings of the time lapse. Chep looks better though. All of the overhangs are definitely better. Again, the top, we still have some gaps, dealing with some under extrusion there. I definitely have to fine tune some settings for this. But overall, it's an improvement. Next up is the Benchy. What would a comparison test be without the Benchy? Again, first, we'll take a look at the stock Benchy. This first layer looks pretty good. There is some under extrusion though, but not that bad. Again, this ringing issue, I can't seem to figure that out. The bow here, there's a little under extrusion where the seam is. The back, again, these zits are just due to the time lapse. The cabin here looks pretty good. There's no stringing at all inside the cabin. top layer, there's some under extrusion there. You can see it between the ribs on the roof. The back, again, this is where it puts the seam, so there's under extrusion, over extrusion for the seam. Little overhang droopage there, but overall it looks decent. Next up is the BMG benchy. Bottom looks better than the stock benchy, but still slight under extrusion. I can see some ringing here. That's definitely from acceleration, so I need to tune that. Layer shifting though looks a little better. Cabin again looks pretty good, but this backside, man, I think that has more zits than I had in middle school. I definitely have some retraction settings to do. But again, it's mainly from the time lapse, so I should probably do these tests without doing time lapse. Overall, it looks pretty good though. I'm not too, unhappy with the results. The overhang looks a little better there. But I have some definite work to get this printing a little bit better than what it is right now. For our last test, we're going to look at the Batman bust. I really like this test because there's a lot to it. There's some sharp curves, quick directional changes, overhangs, and fine points. It really combines a lot of things all into one test. Again, first we are going to take a look at the stock Batman bust. First layer looks really good, as usual. I had the stock settings pretty much dialed in. The layer shifting actually doesn't look too bad on this. The overhang under the support though looks, could use some improvement. But overall, as we spin this around, you'll see that, there's some consistency here. Looks rather smooth. This seam though, it always bothered me. I could not seem to get the seam setting right, no matter what I did. There's some under extrusion here on the shoulders and on the top of the head. The bat ears, they turned out pretty well. They would look better with lower, layer height, but I just went with 0.20 for the test. Again, BMG is second, and the bottom here, actually this is probably the best first layer out of all the BMG tests. Again, slight under extrusion, but not as bad as the others. The ringing though, wow. That is definitely an acceleration issue, and that's due to the extra weight on the gantry. Under the chin though looks better. All of the overhangs look better, actually. And as we spin this around here, we see some zits. And then we look here at the seam, and again, that is, the time lapse. It's just something I have to work on, get better at. The seam though, I'll say looks better. If it wasn't for the time lapse, I don't think these zits would be here. But overall, it doesn't look bad, but it's not great either. I would say that the stocks Batman bust is probably the best one out of these two. So as you've seen in the comparison, the results weren't exactly what I was hoping for. I was hoping to get a little better quality out of the DDX extruder than what I got. I chalked that up to user error though. I didn't want to fault the extruder, so I pushed back when I wanted to release this video. I ended up going through Teaching Tech's tuning guide, which I'll link to that in the description. And I spent, about an extra week going through that guide, just fine tuning everything, trying to get the settings right for this DDX extruder. And this next section is going to go over those results. And I think, as you'll see in the videos, the guide did a really good job of getting better results from the extruder. I'm just going to speed through the videos. I probably won't talk over them much and just let you look and see, the results for yourself. Continuing with the theme, Here are the time lapses for all 3 new comparisons after tuning. First up, we're going to do the chip cube again. If you look quickly, you can see after it focuses, nice sharp corners on the edges, the overhangs on the letters. There's no drooping. Letters have nice sharp edges as well. The back still has zits from time lapse. I don't know what I could do to fix that other than just keep playing with the retraction settings. The chep looks almost perfect. The C has a little drooping, the P has a little drooping, but compare that to the original, it's night and day. Here's the before tuning and after tuning chep. As you can see, there's definite improvement there. The top, a little under extrusion. There's only like a few gaps, not nearly as bad as it was. The bottom still has under extrusion as well, so I have to play around with that. But overall, it's definitely better than the previous 2. Next up, we're going to go through the benchy after tune. Take a quick look here and you'll see the ringing's definitely improved. The layer shifting has improved. But the stringing inside the cabin, that's a new one. First, we've had that since testing. Backside here, the zits looks, well, the zits are minimized compared to before tuning. The bottom, looks pretty decent, but it's the worst one out of the 3. I don't know if I had the Z offset right when I tuned everything or not. The top here looks really good. There's no like under extrusion or anything going on. But still that stringing inside the cabin, I'll have to figure out what caused that. Overall, it's still a good benchy. Lastly, we're going to go through the Batman after tuning. Take a look here. It actually looks really decent. There's very little ringing at all. Definitely improvement on that. Under the chin looks really good. Even though, well, you've seen the issue with the support, and I think that's why we got these zits here. The support kind of gave up on us. I don't know what happened to that. Take a look at this backside here, and this is what I was looking for. This seam is almost as good of a seam as you can ask for. No zits or really any zits at all on the back. I mean, look at the before tuning. Compared to the before tuning, there's zits all over the place. The seam is kind of really inconsistent. The stock setting, the seam really bulges out. It's very apparent there's a seam there. Take a look back at the tuned Batman bust. And there's no under extrusions on the shoulders. There's like a slight bit there at the neck, but I wouldn't complain about that. I mean, compared to the seam, that seam is awesome. The face, really detailed, turned out really well. All the overhangs, there's no drooping or anything. There's a little zits on the ears, but that's about it.
Well, if you made it this far, I'd like to thank you all for sticking it out through my first video. But that was it for the installation of the Bondtech DDX V2 extruder on the Ender 5 Plus. It's a fairly straightforward process and pretty easy to get through. Bondtech even supplies guides on how to do it on their website. Links to them will be in the description. I can definitely see why they came out with a version 3 though. Trying to get this internal bolt that holds the parts cooling fan on is definitely a real pain. I actually had to do most of that off camera because I just couldn't get to it while I was filming. I do, however, have an Ender 3, so maybe we'll see a version 3 kit for the Ender 3, depending on how well this video does. As far as results are concerned, I'm very happy with the results. I did, however, have to spend an extra week fine-tuning, getting all the settings right, but it was definitely worth it, as you've seen in the comparison videos. If you have any questions or comments, you can leave them below. If you like this video, you know what to do. But in the future, I do plan on doing a silent fan mod kit for the Ender 5 Plus, so stay tuned for that. But until then, I'd like to thank you all for checking this out, and I'll see you in the next one.